Good afternoon. It's actually Bracjunova, but thank you for introducing me. Let's wait a little bit until... So, over a year ago, when I was working with a client, I've realized one important thing. Traditional automation is no longer enough. Processes were are getting more complex, expectations are rising, and the technology we relied on had already reached their limit. And then AI came. Later, agentic AI. And that shifted everything on how we look at the automation today. Because AI and AI agents can think, analyze the context, make the decision, and even execute the things, execute the processes. And that actually inspired me to set up a company called AI robocube, where we are focusing on building AI agents for complex processes and driving the success within those processes with the clients. What you will see throughout this presentation is that we're going to walk through how we're moving from the bots to the AI agents. And before we deep dive into that, we'll look into reasons why. So let's ground it first. What we're seeing within the companies today on an everyday basis. People are overwhelmed with the routine tasks. Complexity is rising, ROI stalls. On the other hand, bots, they work. They help us to automate repetitive tasks, but only until nothing changes. When something changes, they stop. And anytime they stop, you need to include developer to reprogram those rule-based bots. So in today's presentation, we're going to talk a little bit more about why traditional automation hits the wall and what is different between AI agents. Then I will share with you a few examples of real transformation or transitions from robotic process automation or traditional automation towards agentic AI. We will share how they approach it, what were the successes, what were lessons learned. Next, we will talk about the smart strategy. It's not always about ripping out whatever exists, but it's more about building on top of it. And then we will talk about success framework in terms of everybody's asking how we are going to control what robots does, what are the guidelines, etc., and how we can govern and make sure that the robots act within the compliance. So let's look on what we are promised. When we were implementing traditional robotic process automation, traditional automations, it was all about the script. We hoped that we're going to automate all the repetitive tasks, return of investment is going to rise, and we're going to scale up within the companies as much as possible. But the reality is that at the end, those bots, when the reality hits, those bots does not work. Right? You have to change them because they cannot really adapt their processes towards new changes. And we're overwhelmed with additional maintenance, which hits normally up to 40%. Even though, as you know, like majority of those automations tend to have fail on the first at the first try because 70% of them not even like scale. Before we move on, let's actually deep dive a little bit into how automation has evolved. So let's have a look on this timeline. We've moved from spreadsheet emails to rule-based robotic process automation. Then GenAI came through with the chatbots, task assistants, and later, like more or less this year, agentic AI. Every stage made us faster, but only one made us smarter. We are currently at the inflection point, and the real question is, where are you? This shift is what I call the perfect storm. There are three forces which are converging. One, it's a business intelligence. Second, technology readiness, and the third, automation limits. If we look on business complexity, as you know, data are growing. We work with more and more data. Complexity is rising, and in the meantime, I'm sorry. At the same time, technology has evolved. We have available AI models which we can use and which we can scale. Infrastructure has also scaled, so it's much more available, and we can recalculate all those AI models much more easily than we did it before. But at the same time, automation hits its limits. We cannot scale, complexity is rising, and actually it forces companies to move towards something which is more intelligent, like the agents opportunities, which are now at the inflection point of those three forces. It's not more about whether we want or can automate and use and build the AI agents. It's about the fact that we really must do it. As I've mentioned, we do have a rising complexity. We do have limits and increasing expectations from the customers, and that's why this is really becoming a reality. It's not something we only talk about, but we're really implementing the AI agents in reality, and you could see it with the multiple customers already in place. So before we explain why we are moving from standard and traditional automations towards AI agentic, let me show you what's the difference. Imagine traditional automation as hiring the world's most effective assembly worker. It executes what is being told to do. It has great effectivity, accuracy. Never take breaks, never complains. But until reality change and hits this automation. In that case, what happened is that we need to involve developers to reprogram those bots, and it costs you additional maintenance, etc. So it means that those traditional automations actually hits the wall and cannot scale going forward. On the other hand, imagine AI agents as hiring experienced business consultants. You don't tell them how to do exactly the process, but you tell them, this is my goal, what I want to achieve. These are the rules and constraints I want you to work in, and these are the tools. And what it does is actually it's capable to make a contextual decision. It can understand the data. It can adapt when conditions are changing. Even though if something new appears, it can learn and include it into learning and future decisions. And critically, it can explain the reasoning, why it did that way within that exact step. So let's have a look on what is covered under the hood. When we are programming traditional bot, or for the RPA or for the scripting, what you do is you use if and then conditions. Whereas, like, if something appears, basically trigger appears, rule engine analyzes it, predetermined action executed, log the results, done. There is no adaptation, there is no learning, nothing. On the other side, AI agents work in loops or in the circles. They work against the goal. So when something comes in, they analyze the context, they plan, they can make action, they evaluate the result, and they keep learning. So it's like a circle which goes all around and keeps you adapting over the time. So how those agents are really working and what makes them so transformative? It's very, as I've mentioned, it's a very simple loop. It starts with the perceiving. It can read the emails. It can work with your system. It can log into databases, and constantly is aware of the environment in which it is working. Then it takes that data and think, this is where the LLM models, reasoning, learning steps in. Basically, it evaluates, it analyzes the context, then it comes up with a couple of solutions, then it evaluates the results and make a decision. Once the decision is made, it executes. It goes throughout your systems, into your databases, can write, rewrite, or even trigger a new automation flow. Once they're done, it evaluates the results, so it's actually learn. Based on that learning, it includes it into the circle again, meaning that whatever can be done better, lighter, smarter, it's included in that circle and in that loop. So let's move from theory to a practical use cases. Let's start with the logistics. Let's start with the logistic company. It is a real use case we've already implemented. It's a regional freight company with 127 trucks across Central Europe. It took 8 dispatchers to plan. Each of them were planning like for 6 hours routes for the respective orders for the upcoming day. They had to work through 7 different systems with up to 50 parameters, and it still didn't solve the problem because they were optimizing for the distance, but not with the profitability. So if we would choose traditional programming in this case, we would have to set up all 47 parameters with if then work this, and if this situation happens, do this and this. We would have to set up over 100 different exceptions, and the problem would still pertain. It would optimize only for individual routes and can't really balance the trade-offs with the overall route planning. Instead of that, we've selected and went with agentic AI, which allows us to think differently and look on the problem from the goal-setting perspective. So the client has decided to go with the goal and completely reshaped the position how this process was executed. So we've set up a goal, maximize fleet profitability over 7 days, rolling periods, while maintaining service excellence and driver satisfaction. An agent actually worked around this goal. What we have achieved was we had an agent who was capable to take the orders which were coming into the pipeline from the customers, even plan them ahead, so we were able to get it into the 7-day forward planning vision. Whenever it calculated the routes and took into account available drivers, their conditions, their driving permissions, planning the routes through the route mapping, it was looking at the profitability first. So instead of just focusing on managing and meeting customer requirements from the order perspective, we have started looking on the profitability of each and every route and satisfactions of every customer and every driver. So we didn't only optimize the empty kilometers, but we also included humans in the loop, which is one of the control we've implemented into this solution. So agent planned everything, but it was like final decision of that respective dispatcher to move forward with that. That allows us to move thinking from managing individual parameters into the managing goal and outcomes. So, I'm going back. So let's move now from logistics to data and sales. Another use case, bakery manufacturing company had to create 23 reports on a weekly basis in order to manage their sales and see how the customers are performing. Sometimes it took like a days in order to prepare it with the support of the IT, with the support of business analyst. But those reports cannot really ask cannot give you a response on the follow-up questions. And the problem was that the data were coming not at the time when you really needed them. What we've done is we've implemented prompt-based intelligence over the existing systems and over the existing data. It meant that anybody in the company could type in any questions. I don't know, what is the discount I've provided for this respective customer, or what is my revenue for this segment, and it gives you the instant chart, instant data, opposed creating the report. It was capable, and it is capable actually, to connect through various systems, data, so it can go to your financial systems, CRMs, even external data, because we are using some like weather predictions in the bakery. It is quite an important, because if you have a sunny weather, then there's a big chance that people would buy a little bit more like buns for hamburgers, for the grilling. So those are all the aspects you can include into that, and through the basic prompting, the intelligence is able to provide you with the recommendations, with instant data and insights on anything you asked for. And what is good about it, that you can program it for the specific customer politics or behavior. So whether it's industry in bakery, whether it's logistics or any other industry, you just, through the prompting, learn and acknowledge this system in order to behave the way you would like to do. So you're actually giving it personality based on your preferences within how to look on the company data. So now we've looked on a couple of examples, but how do we really make it happen? as you could see, both of those solutions didn't rip out the existing systems, but we add intelligence on top of it. And that's the approach. I'm sorry, it's not. Oh, okay. So, and that's the approach we're choosing in every solution. We are trying to keep what is working. We are not taking out your existing CRM systems and any robotics or whatever works. But we build the intelligence on top of it. We are adding the additional layer. So you build on what is really working and expand the business and intelligence on top of it. We've built, let's say, let's call it like a 4-layer stack, which integrates together and works together. And without that, we wouldn't be able to implement those AI agents. First is foundation layer, work built on what already is in your company. As mentioned, whatever you already have. Then what we're doing is we're adding intelligence on top of it. So it's LLM models, reasoning, and all of that, which is going to increase the success of executing the process. Third part is so-called orchestration layer. That's something which helps us to connect all the systems you have, connect people in the orchestration, as well as agents or bots, etc. And on top of it, it's so-called governance layer. Governance layer is something which allows us to control it. So it's instant reporting, governance rules by which that agentic robotics work. So how do we design bots based on that? Once we've got a framework, then we move into the design of the bots. If we would go with a traditional process design, we will have to program each step separately. So first, second, third, etc. Whereas when we're talking about agent-oriented design, we completely flipped the logic around that. You are not setting and you are not programming each and every step, but you start with designing the goal. In this case, resolve customers' issues quickly while maintaining satisfaction and following company rules. Once you set up a goal, the second is that you need to set up a success metrics, because you need to know how the robot is performing, and based on that, you are capable to redefine either the goals or either the rules or whatever is set up inside. Third thing, you are setting up is the constraints and rules. You are telling your agent what he's supposed to do, what he's not supposed to do, what are the limits, what are the constraints, so you can actually build a control around it. And then you tell agent robot what tools to use. And that's how we make agentic AI or AI agents to make decisions. The next step, once we made robots or AI agents to make a decision, it's about how we control them, right? And this is where the most leaders need to shift in their leadership, because in this case, we're moving from traditional system programming where we have checked every step robot has been doing to managing through the goals and through the KPIs. So it's like more, we're not looking on what the bot didn't click, what it did do, didn't do, but we're looking on the outcomes of the robot. So whether it met customer satisfaction or whether it met the policy compliance, etc. And based on that, we redefine, again, the goal, constraints, etc., until we meet the required level of those goals and those metrics. Let's move into a little more details in terms of how the control framework works, because that's the most discussed topic on when we let AI agents work. How do we secure that they act within the framework we would like them to work? So we have 5 layers or 5 areas which we are using in order to set up that control. As mentioned before, you need to set up a clear boundaries, really define what agents can and cannot do. Second thing we've mentioned is that you are setting something you are going to measure their success against, and that you need really monitoring the strategic outcomes. So you're tracking really the goals, but you are not tracking the micro steps within the process, whether it has been done or not. Third thing, which we are adding into AI agents is a transparency, meaning every step has to be explainable. So we're adding the explainability over those agents, so we can have a look on why it did it, what was the reasoning behind it, why this decision has been made. Fourth thing is we're adding humans into the loop. We're not replacing humans, but we're actually letting them cooperate with the agents, but at the end, human is always in the control. And the last thing is continuous calibration. It means that you are not going to develop the AI agents at the first time, but you still have to somehow calibrate, test, and make sure that it meets the required level of outcomes you are targeting it to. Talking about how do we engage people or humans in the loop, normally we're seeing 3 layers within the customers. First one, the one with the minimal risks, is where the human approves every decision. What does it mean is that AI agent prepares you, I don't know, for example, loan, right? So if you're preparing a loan, so it prepares all the documentation, but at the end, it's a human who decides whether it's correct or not. Then it's a second level, where a human monitors agent decisions. So humans are just monitoring and involved in certain cases based on the constraints you are setting up. And the highest level is when agent acts independently, mostly, for example, for customer services, where you let agents really work within the constraints completely autonomously. Our experience is that in most of the cases, we start at the second level, where we set certain limits and let people monitor the agent work. And then as the trust, data maturity grows, we elevate to the next step. We've covered today why traditional automation hits the wall and why when automation hits the wall, and what's the difference between the AI agents. What is important is to realize that when we're building the AI agents, it's like a completely different mind shift in terms of how they act and what we're managing. So we're not managing steps, and we're also like managing the goals. I've shared with you real cases from where the logistics started managing the profitability, and sales data are become conversational. Practical implementation strategy you don't have to rip out your existing systems or what is working. Move to more evolve and then replace and build the intelligence on top of it. The last, but always discussed a lot, is the risk management framework, and it's about the governance from the day one. You have to, and we have to build actually the explanatory audit trails in order to go back to the agents and find out why it decides that way and how we can use that for the future learning. So the whole intent of this presentation was not about explaining how it all works, but really that we're at the stage where we need to change the mindset how we're looking at the automation right now. That we are moving from telling machines how to work to telling them what we want to achieve. That's all from me today. I don't know whether there are any questions.
All right. Give it up for Viktoria. Do we still have time for questions? All right. So we pop them up. I'm going to start with the most voted, Viktoria. We got comparing the costs. How costly is the implementation of the agentic AI in comparison to the RPA solution?
It's not such a big difference. Because the way how we're programming agentic AI is also through the agentic AI. What we do is we just set up the goals, frames, constraints, etc. That's the biggest part of the investment you have, which is the analytics and setting up the outcomes. But then we take it and get it into the framework, and the intelligence creates the prompts. From prompts, we're creating scripts, and that is how we are automating whole processes. So, whereas with the RPA, we had to program each and every step, and that was the main process which took us the longest. Now, the development itself took us only, it normally takes us like a few days, and so it's very comparable, like from where we are. Where we were before and where we are now from the programming and from the cost perspective.
Okay, nice. Questions keeps coming in, so it means you triggered something. The next one is from Matt. Did you utilize an existing model or trained one yourself?
We have trained ourselves, one of ourselves, because we're focusing on manufacturing, and manufacturing is still not very open towards the cloud solutions, so we had to train ourselves.
Okay, clear answer. How you test the agents or the agent orchestration?
So first, it's in so-called shadow mode. We are running the AI agents together with real production, and we are redefining the goals and setting up the constraints, etc. And then we move to the next stage, which is controlled production, where we are letting agents to make a decision, but people act on it, and as they build trust and as we fine-tune that model, then we're putting it into production.
Okay, nice. And then we have a liability question. Liability question, lightning round. Who is legally responsible for life, health, revenue loss due to the bad agent decision? No idea what I just said.
I said, it's about making sure that you put controls into that agent. So before it goes live, we test it to the extent that it should not cause that. And of course, you are going to have a revenue loss probably because it's like a process, but that is the part of the overall benefit and outcome.
Okay. I'm going to probably pronounce it wrong. How Queria, is that right? Queria?
Yeah.
difference from ThoughtSpot application, the asking question to the visualization tool is kind of their out-of-the-box offering as well.
I don't know ThoughtSpot, so I can't really.
Okay, well, that's a tough spot. It's getting late. How do we prevent the agents from becoming overfitted?
Okay, I'm just wondering what overfitted means.
Trained, going to the gym, doing triathlons. If you got an agent that is too pumped,
And that's bad, right?
yeah, it will get too strong, and then, well, I'll answer that for you. You combine the cardio with the physical, and then your agent will be okay. There you go, we tackled it.
Thank you.
Are there different ways to implement the AI agent, or is there a general approach?
I think there are a lot of theories and practical applies how you can develop the AI agent. I was telling about the approach we have taken, but you do have a lot of platforms which allows you to create the agents which work completely differently.
Okay, and then the last one before we close off and go to the tent and close off OpenSlava. What are the key components of an AI agent?
I'm just thinking how to take the components. It's basically a script, right? Scripting is the component for the AI agent, but it works around goals, around the constraints you are setting it up, and about the orchestration layer. How do you include it into your operations? So that orchestration layer, I've been talking about it, about the controls you're putting into that. Those are the components of the AI agents.
Okay, and that being said, being the key components, I would like to thank you for closing this conference, definitely on this stage. Viktoria, thank you so much.